Chapter 1 Trigonometry, Section 1.2 Right Triangle Trigonometry. Yeah, we will learn the properties of right triangle trigonometry, especially Pythagorean theorem, then the trigonometric ratios on a right triangle, and the trigonometric values of well-known angles, and the reciprocal relations between the trigonometric functions, and finding the trigonometric values of an angle in standard position. Let's start with Pythagorean theorem. Basically, Pythagorean, as you know from the figure, if you have a right triangle with these sides A, B, C, and C is the hypotenuse, then this A, B, C has to have this relation: A squared plus B squared is equal to C squared. So this is Pythagorean theorem. And its converse is this. So if you have three numbers like A squared, B squared equal to C squared, they're all positive, then you can form a triangle this way. So it's the converse of the Pythagorean theorem. So we use Pythagorean theorem generally. Two sides are given, and the third side we want to find the third side. We use this Pythagorean theorem. And the converse, generally, we give the numbers A, B, C, and then ask, is it a triangle? Do they make a right triangle? So this type of questions, in this type of question, we check here and say yes, they can make a right triangle. Okay, let's apply the Pythagorean theorem. Find the perimeter. The perimeter means muhit in Arabic, muhit, of the right triangle whose sides are 2x, 2x plus 2, and 3x plus 1 units in length, where 3x plus 1 is the longest length. Okay, here, this is the situation now. We have a right triangle, and the biggest side is 3x plus 1, and 2x, and 2x plus 2 is the other sides. And we set up the Pythagorean theorem. We want to find the perimeter. So perimeter means we will find here, and then here, and then here, and then we will add the lengths. So the perimeter muhit will be the length of BC plus CA plus AB. So it's asking these sides. So in order to do it, so we have to find x first. So in order to find the x, we have to set up the Pythagorean theorem. Okay, I will skip. I will use this solution in the slide here. So it's 2x squared. This is a, let's say a squared. So a squared we write, and then b squared. Let's say here it's b is equal to c squared, and this is c. Then after we expand, we get this one, and then we try to solve a quadratic equation. And after doing this, send and send here, then we get a quadratic equation equal to 0. And then how do we solve it? We can use quadratic formula, or we can use factoring. So if you use the factoring, you will get two values here, x equal to 3 or x equal to -1. And here we don't take this one. Why? Because the length is positive, because here it says 2x. So x is positive because it is used in length. So we take x equal to 3. Then how do we get 6? So this is 2x. As you know, this is 2x plus 2, and this is 3x plus 1. Then you put x equal to 3. When you get these values here, 6, 8, and 10. You find it. Now we find sides 6, 8, 10. Now you can hit them here. And how do you find the perimeter, Mohit? So you add these three sides, the length of the three sides, and you got 24 units. Okay, let's look at another example. In this example, it said determine whether a triangle with side lengths 2 centimeters, 3 centimeters, and 5 centimeters is a right triangle. So the question is, okay, there's assume you have a triangle like 2 here, 3, and 5 here. So is it a right triangle? So it is asking, hey, is this like that? So okay, and also it might not be a triangle as well, but we will check if it is right triangle or not. So basically, we check the converse of the Pythagorean. So if it's a right triangle, then it has to satisfy the Pythagorean, and if it satisfies the Pythagorean equality, then equation, then it will be a right triangle. So we basically check 2 squared. So we are checking this one, 2 squared plus 3 squared, is it equal to 5 squared? So obviously this is 13 and this is 25 and this is not. They're not equal, so we say that triangle with these sides cannot be a right triangle. Okay, in this try and check exercise, we have the same type questions. Please stop the video and try to do it by yourself and check your solution with mine. Now, A, find the area of the right triangle whose sides are x, 2x plus 2, and 3x minus 2 units in length, and where 3x minus 2 is the length of the hypotenuse. So I will do it here. So we are given a right triangle, and the biggest side here is the hypotenuse is 3x minus 2. Yeah, this is given in the question because, for different x values, this might be the biggest and this might be the biggest, or yeah, this might be the biggest, but so for this reason, we have to check which one is, at the first hand, we have to know which one is the biggest. So in the question, it says the length of the hypotenuse is 3x minus 2. Okay, then we place the others. Then we set up the equation. And then we try to solve it. Okay, this x squared and 4x squared. So send them to this side, you will get 4x squared. This one, send it to the other side, you will get negative 20x. And 4 and 4, they cancel out, and you got this one. So when you solve this one, it will be 4 times x squared minus x, which is equal to 4 times x minus, okay, sorry, this is 5x. This will be equal to 0. So we have two roots here, x equal to 0 or x equal to 5. Then this cannot be 0 because of this here. This is positive. The x should be positive. So because the side length cannot be negative or 0, so x should be 5. And One other thing here is, okay, we got x equal to 5, then we can place it to x equal to 5, and then we say that our triangle is this. 2 times 5, it's 12, 2 times 5, and it's 5, and this is this one here is 3 times 5 minus 2, so which is 13. So we have this triangle. Okay, it's asking the area of the area. Area means here musaha. Okay, so how do you get the area here? The area formula for the triangle is, remember, this will be base times the height divided by 2. The area musaha is equal to h times b over 2. So I will use the same thing here. The area is equal to 5 times 12 over 2, and then it will be 30 units square. You know, here these are 5 units. This is units. So keep in your mind this unit times unit, it's unit square. Or we write unit square. Now let's do the other one. Now let's look at the naming the sides of a right triangle with respect to acute angles. Okay, now first the side corresponds to 90 degrees, always called a hypotenuse. Now, we have two acute angles here. One of them is, let's say, beta, the other is theta. Now, okay, for now, forget about beta and concentrate on theta. Now, this side, next to theta, is called adjacent side for theta. Adjacent side, so it means it's adjacent means it's the neighbor, it's next to it. Now, we call AC as adjacent side for theta. Now, this here, we call this one the opposite side for theta. So this is called opposite side for theta. Now, BC is opposite side for theta, and AC is opposite side for theta. Now, let's concentrate on beta. Now, let's look at here. Okay, forget about these. Now, I'm thinking the same thing for beta. Now, what is the adjacent side for beta? So I will say the, okay, this is adjacent side, sorry. So the adjacent side for beta. Okay, what is the adjacent side for beta? So let's look at here. Beta, there are two sides next to beta. Here the hypotenuse. We don't take it as adjacent. So it will be the adjacent side will be this one here. This is adjacent for beta. So BC is adjacent for beta. Now, what do you see opposite of beta? So this, you see AC, Now AC becomes the opposite side for beta. So AC will be opposite side for beta. Now in Arabic, it's opposite side. Opposite side means مقابل, مقابل, and here adjacent is مجاور. Now the adjacent and opposite sides are with respect to the angle. So you have to specify the angle first. I mean, if you're saying the opposite side, but for what angle? Which angle? So you have to specify the angle, because if you don't specify the angle, there's no meaning to say adjacent side. So if the angle should be specific, you have to specify it when you talk about the opposite and the adjacent side. Okay, here is what I told you. It's written here for theta, CA, and is the adjacent side, BC is the opposite side. For beta, the adjacent side is BC, and the opposite side is CA. And the hypotenuse remains same for each angle. So we don't call it opposite side or adjacent side. We call just hypotenuse. It's out of our list as adjacent or opposite. Now this is important because we will use these sides when defining the trigonometric values of an acute angle. So here is the situation. Okay, this is our theta, let's say, and the adjacent side of theta, let's say this is A, and the opposite side is B. And now this is C, the hypotenuse. Now, these ratios, the ratios of the rates or ratios of these sides remain same. So you can make a big one, but when you talk about the ratios here, it will be same for each triangle in the same way. Like each right triangle here, you can make them bigger or smaller, but the ratios will remain same. So they make kind of a measure of, I mean, they become a specific property of the angle. Now, here the cosine theta, we define it this way: the adjacent side of theta, okay, to theta or of theta, and the adjacent side for theta divided by the hypotenuse. Mujawir divided by hypotenuse gives you cosine. So this divided by this one. So we write cosine theta is equal to A over C. In the same way, sine theta is opposite side divided by hypotenuse. The opposite side here divided by the hypotenuse. And the tangent is opposite side B divided by A. And the other secant theta is indeed hypotenuse divided by adjacent. But you can think of this one here. Look at here. So they seem to be connected because hypotenuse, adjacent, adjacent, hypotenuse. So if you see this here, C over A, this is A over C, you can write here, this is indeed 1 over A over C, which is cosine theta. Now, in the same way, cosecant theta has the hypotenuse divided by opposite side. It's connected to sine theta. You see, opposite side, hypotenuse, hypotenuse, opposite side. So this is 1 over, this is B over C, and this is C over B. So it's flipped. So we say it's sine theta, 1 over sine theta. It's reciprocal. And the same way, tangent theta and cotangent theta has the same relation. And one is the reciprocal of the other one. So these trigonometric values you have to memorize. Okay, you have to memorize them, because when we have such thing, the triangle, you have to know. If we ask you cosine theta, you should say, okay, it's mujawir divided by hypotenuse, or the adjacent side divided by hypotenuse, or sine theta, opposite side over hypotenuse. At least you have to know these three of them, and then the others follows from here, the reciprocal rules. Now this is what I'm talking about, the reciprocal relations, and it is clear from the table. Now, finding the trigonometric values of an acute angle and vice versa. Okay, let's concentrate on these problems here. Find the 6 trigonometric values of theta if theta is the measure of the angle ABC, where BC is 4, AB is 5, and the measure of the angle ACB is 90. So here we see some angles, and here we have 3 letters, so it will be a triangle. And we have to, okay, first we have to set up the triangle. Okay, first set up triangle. Now, in setting up the triangle here, if someone is asking the trigonometric values, it's most likely the triangle is 90 degrees, the right triangle, but it doesn't have to be, by the way, but you will check the conditions given, the properties of the triangle here. BC is 4, AB is 5, and MACB is 90. So we have one of the angles is 90. So here we will set up the triangle. But we will put a 90, of course, here 90. One of the angles is 90 degrees. But here the important thing here is this: is it like ABC, or is it like ACB, or is it like, you know, it might be like BCA, or, you know, different ones. We can have different, you know, orders of ABC, ACB. Now, the key thing here is, the key information here is this one. The measure of the angle ACB is 90 degrees. So always start with 90 degrees. And here it says, so you will, by the way, you will check the center here. The center is C. The center letter is C. And then you have to put C for 90. Okay, for the others, we don't have specific instructions, so we will say theta is equal to ABC, but after we put A and B. Now, there is no other specific thing about A, B, their, you know, their measures, except theta. Then we can set up this way, then A here, B here, or you can set up this one, B here, A here, but C is fixed. Okay, C is fixed because it says C has to be 90. Okay, now I will erase this one and do the work with this one. Now, what is it? BC, BC4, and AB is 5. Okay, we have this one. Now, the other thing is, where is this? ABC is theta. Okay, B, center letter, I mean the middle letter is theta. So you go to B and you say it's theta. Roughly B is equal to theta. You can say that, theta. Now we set up the triangle. Then the second thing is, okay, find all sides and then write trigonometric values. Now, is this missing? I mean, is one of the sides missing? Yes, AC is missing. So how can we find it? How can we find this AC? So by Pythagorean, you can say AC squared plus 4 squared is equal to 5 squared, and this AC squared is equal to 25 minus 16, which is AC squared 9, is AC is equal to 3. Now, by using Pythagorean, we got this one, 3. Now, I'm erasing this. So since this is a video, you can play backwards. So if you have something you're missing, you can look at it. Okay, you can watch it again. And then we have this one. Now we can find the trigonometric values of theta. Cosine theta is what? Okay, this is the adjacent for mujawir, adjacent side of theta, and this is the opposite side for theta. Okay, we keep them in our mind for theta. Then what is cosine theta for? Okay, the adjacent side divided by the hypotenuse, which is 4 divided by 5. And what is sine theta? It's opposite side divided by hypotenuse. Okay, one thing, memorizing this will take time. So how do we memorize such things? You can use some memorizing techniques, but it's better you do more practice. The more you use it, the more you memorize it. So opposite 3 divided by 5. The hypotenuse is this one, by the way. Hypotenuse. So it will be 3 over 5. And tangent theta is the opposite divided by the adjacent. So it will be 3 over 4. And what is secant theta? I will just say 5 over 4. And what is cosecant theta? It's 5 over 3. And this cotangent theta is 4 over 3. So these are the 6 trigonometric values of theta. So the idea is set up the triangle and then find all the sides and write the trigonometric values. Okay, it says find the length of all sides of the triangle ABC if ACB is 90 degrees and BC is 12 and sine theta is 1 over 3 and theta is the measure of the angle ABC. Now first we have to set up the triangle. Okay, first we draw it and let's try to locate what is 90 degrees here. Which one? A, B, C. Which corner is 90? So here you have to look at here the middle letter here, that's in the middle. So it's 90 degrees, so you have to say this is C now. Now, then you can set up A and B. You can write A, B as you wish, but 90 degrees is important. So this gives you the figure. And BC here is telling us this is 12. Sine theta is 1 over 3. And what is theta? Theta is this corner here, B. So you always look at the middle letter here. So it's theta. Now, what is given to us now? This figure is given, and sine theta is equal to 1 over 3 is given. So how can we use these two information to get the sides AC and AB? And BC is already 12. Okay, we will try to find the sine theta by using the triangle. Okay, what is sine theta? Sine theta here is the opposite side of theta, or for theta, and divided by the hypotenuse. And this is equal to AC divided by, so AC is the opposite side for theta, as you see. This is the hypotenuse, and now it will be AC over AB. And we know this is equal to 1 over 3 from here. Now, how can we proceed from here? So in this case, it's better to proceed with an easy variable here. I would say AC, let AC equal to X. Now I will try to find AB in terms of X. So then it will be 3X. So you can do this cross multiplication. You will see now And then we can write the triangle this way. Then x AC is x, and then this is 3x. Now in this way, we converted everything to x's now, so we can solve the Pythagorean. So we can solve the triangle by Pythagorean theorem, which says x squared plus 12 squared is equal to 3x squared, which is 9x squared. So then this will give you 12 squared is equal to 8x squared. And this will give us x squared is equal to 18. Okay, do the job here. Okay, you can do this one. I'm doing a little quick. So the x will be here square root 18, which is equal to 2 square root. No, not 2 square. 3 square root 2. So okay, guys, check this out. So I'm skipping the steps here. So these are the basic steps. Now x turns out to be 3 square root 2, and now I got this one. Now AC is equal to 3 square root 2 from this x, and now AB is equal to, we know it's 3x here, so A, B, C. Now this will be 3 times 3 square root 2, so this is x, this is x also. So AB turns out to be 9 square root 2. Okay, it's done. Now, use the reciprocal relations and the Pythagorean theorem find other trigonometric values of an acute angle if cosine theta is 1 over 2. Okay, guys, in this question, you can set up the equation, set up the triangle this way. Cosine theta is 1 over 2. You can say this is theta, and the relation between the adjacent, okay, what is this, cosine theta? Cosine theta is the adjacent side divided by the hypotenuse. So what does it say? The adjacent side here will be this one, and the hypotenuse is 2. Okay, and here it's adjacent one is 1. Okay, one thing I want to warn you here is when, okay, you can put these values, okay, on the triangle. If you want to find the other trigonometric values. And plus no length involved in the question. Okay, no length. So nothing, there's nothing about length here. Nothing about length. So if one of the length is given, then you cannot make 2 1. Okay, it's just for the ratios. We are doing it for the ratios. If the length is given, you have to be careful about the ratios, because cosine theta is just a ratio. So this is just a ratio. So what I mean here is that the real triangle might be like 1. Let's do it this way. Like it might be 1 2, like 2 4. It might be like 3 6. I'm talking about just nisbah ratio. Okay, so if the length is involved, you cannot use this method. I'm warning you. Now, if only I will use this one to get sine theta and tangent theta, then I can put them here, and I can get this leg, this opposite side, the opposite side squared plus the adjacent side squared is equal to 2 squared. The opposite side turns out to be square root 3. And here, then I can use the opposite side divided by hypotenuse, so which is equal to square root 3 over 2. And then this one here is opposite divided by adjacent side, which is equal to square root 3 over 1. And you can do the rest by using the reciprocal relations. So here we got secant alpha, secant theta is equal to 1 over 2, which is 2. And from this one, cosecant alpha over cosecant theta, it's 1 over sine theta. So you flip, and the cotangent theta is, you flip this one, it will be square root over 1. So here is how we get them. Okay, that's it. And again, I'm warning you, it just gives you one trigonometric value asking the other. So in this case, you can set up the triangle this way, but if one of the lengths is given, so you cannot do this. Okay, this is the solution of the examples here. Here there's the solution written here. You can also check it out. You can read. And here, the last one I did. Okay, let's do this, try and check exercise. Please stop the video and try to do it by yourself. Then I will do it, then you can check your solution with mine. Find the 6 trigonometric values of theta if theta is the measure of the angle ABC, where AB is 3, AC is 1, and ACB is 90 degrees. Now, first we set up the right triangle. Okay, let's set up the triangle. And here ACB is 90 degrees, so C corner will be 90 degrees. Okay. And you can write AB here as you wish, but C is important, And AB is 3 and AC is 1. And yeah, these are given. And the theta is corresponding to the B corner, so it's just theta here. And then it's asking the values of the trigonometric values of sine theta and the others. Now for cosine theta, we need the adjacent side divided by the hypotenuse. So cosine theta, okay, look at here, cosine theta, what is the adjacent side for theta? This is the adjacent side for theta. So we need to find BC. So this is BC, our AB is will be the cosine theta. Now, what is BC? So how can you find BC? BC squared plus 1 squared is equal to 3 squared, and which gives us BC. Okay, I'm using Pythagorean here. So BC will be equal to square root of 8, and if you simplify it, it will be 2 square root 2. And now you can write this in here, 2 square root 2 divided by AB. AB is 3. Now I will erase this part and I will say this here. Okay, I don't need that. Now I have all the sides. Now I can write sine theta. Sine theta is the opposite side divided by the hypotenuse. The opposite side is 1 for theta. Okay, the opposite side for theta is this, AC. AC divided by the hypotenuse will be 1 over 3. Now the tangent theta is the opposite side divided by the adjacent side, which is, okay, opposite side is 1. and the adjacent side is 2 square root 2. And we can do cotangent now. Cotangent theta is automatically 1 over tangent theta, so it will be 2 square root 2 over 1. And secant theta, I can say secant theta is 1 over sine theta, which is, no, sorry, this is not true. Sine theta, its reciprocal is cosecant theta, which is 1 over sine theta, which is 1 over 1 over 3, so you have 3 over 1. And for cosecant, I mean for secant, you can use cosine theta. So secant theta is equal to 1 over cosine theta, which is, you flip this one, and then you got 3 over 2 square root 2. So we got all the trigonometric values of theta. Now find, okay, again, stop the video and try to do it by yourself. Now let's do it. Find the length of all sides of the triangle ABC, where this, the measure of ACB is 90, BC is 14, tangent theta is 1 over 3, and then theta is equal to the measure of the ABC. Now let's set up the triangle, and let's try to put what is given about ABC triangle. ACB is 90 degrees, so C corner will be 90 degrees. So this will be C then. Then we can put A and B as we wish. So BC is 14, and theta is ABC, so theta is B corner, so it will be theta here. And tangent theta turns out to be, okay, tangent theta is given, it's 1 over 3. So it's given, so it's asking what is AB. So the length of all sides, AB, BC, and AC. Now we know this is 14, we know it. Then we have to find the others. So how can I find the others? Now, I will use these two information here. One information is tangent theta is 1 over 3, and the other is this triangle. Okay, we can try to calculate tangent theta by using the right triangle. So tangent theta is the opposite side of theta, or for theta, and then adjacent side for theta. So what is opposite side for theta? This will be AC, and divided by what is the adjacent side? It's BC, so it's 14. Now AC we don't know. Now we can match these two tangent thetas, they are same, so their values are same. So 1 over 3, you can set up the equation now, AC over 14. Now this will give you, okay, 3 times AC is equal to 14. Now AC turns out to be AC turns out to be 14 over 3. Now you can write here 14 over 3 then. Now how can you write, how can you find AB? Now we can use Pythagorean. By Pythagorean. AB squared is equal to BC squared plus AC squared, and AB squared is equal to 14 squared plus 14 over 3 squared. Okay, and if you do the calculations and you can try to do it by yourself. It's a good practice of fractions, and it will be 14 square root 10 over 3. Okay, you can check it yourself. It will be 14 squared 10 over 3. So we got all the lengths. Okay, let's look at the cofunction identities. The cofunction identities are mainly the relation between theta and its complement, 90 minus theta. So theta here is, we assume theta is an acute angle. Now these are, complementary angles. So we will see the sine theta is equal to cosine 90 minus theta, and cosine theta is equal to sine 90 minus theta, and the others. Now I want to show where does this come from, this identities. Why do we have this relation sine theta is equal to cosine 90 minus theta and sine theta is equal to sine 90 minus theta? Now the first thing I want to show you is this right triangle, and let's say this is ABC, and let's say this is theta. Now, what is the opposite side for theta? It's the AC. And what is the adjacent side of theta? It's BC. Okay, now, yeah. So what is the other triangle? I mean, what is the other angle? So this one here is, so there's sum, this is 90, so the sum of this angle theta and this angle here will be 90 degrees, so this has to be 90 minus theta. So when you add all of them, like this one and theta, it will be equal to 180. So it's clear that if one of the angle is in a right triangle, if one of the angles, the acute angle is theta, then the other one is 90 minus theta. Now let's write the sine theta by using the formula. What's the formula? What is the opposite side of theta divided by the hypotenuse? So the hypotenuse is here. Now you see here, this opposite of theta here is AC, and it's divided by the hypotenuse, which is AB. Now let's try to write cosine theta. Okay, cosine theta, which is equal to adjacent side of theta divided by, so which is BC, divided by hypotenuse. So this is the hypotenuse AB, and the adjacent of theta is BC. Now let's stop here and let's try to do the same thing for 90 minus theta. Okay, what is sine 90 minus theta? So this is the opposite side of 90 minus theta divided by hypotenuse, right? So what is the opposite side of 90 minus theta? So this part here, this one will be BC, will be also the opposite side of 90 minus theta. So we say it's equal to BC over hypotenuse is always same in the right triangle, which is AB. Now, if you look at what we found here, BC over AB and BC over AB, it's there. So we have cosine theta is equal to sine 90 minus theta. So in the same way, we can find this cosine 90 minus theta is equal to the adjacent side of 90 minus theta. This is the adjacent side of side 4 or of 90 minus theta. So this is AC, so it will be AC divided by the hypotenuse, which is AB. Now when you look at here, this is equal to this one. Now it means cosine 90 minus theta is equal to sine theta. Now, so from these relations, now one can do the same thing for the other trigonometric values, and then show sine theta is, okay, we already have shown this one, and cosine theta is equal to sine 90 minus theta. And in the same way, we can show tangent theta is equal to cotangent of 90 minus theta, and secant theta is cosecant 90 minus theta, and cotangent is tangent 90 minus theta, and cosecant is cosecant theta is equal to secant 90 minus theta. Now here we call them cofunction identities, because here we have, for these for these two angles, we have cosine. Okay, sine, and there's the cosine. So you see this and this is the tangent here, tan. There's a cotan. Okay, cotangent here, and then here the secant, and we have cosecant. So here we have this cosecant. Thus for sine, we have cosine and tangent, cotangent, secant, cosecant. Now these and their cofunctions, what are their relation here? Is this here? Or sine theta is equal to cosine 90 minus theta, the complement of theta. Cotangent is equal to, or tangent is equal to here, cotangent 90 minus theta. And here secant is cosecant 90 minus theta. And in the same way, you can switch the place of tangent and cotangent, and you can get the same things here. We have 6 equalities, and they're all about the complementary angles. So here, these are acute angles here, both theta and 90 minus theta. They're both acute angles, and we have cofunction identities between them. So this is giving an advantage of using one angle to find the trigonometric values of the other one. Now, here I will show you some special angles and their trigonometric values. These are well-known angles, and their trigonometric values are easy to find. So for this reason, they are very well-known angles, and their trigonometric values has to be known. Without calculator, you should be able to tell them from your mind. Okay, you have to memorize. So basically, when we ask you cosine 60, sine 30, or sine 45, and all the other trigonometric values of them, you should be able to tell them without using a calculator. Now, there are several ways of calculating them or memorizing them, but I want to tell you the method we use, or I use. Math teachers, most of the time, they use these triangles here, because if you know the meaning of the trigonometric values on a triangle, then the rest is easy. First thing is 45 degrees. You see it's 45, 45. If we have a 45-degree right triangle, we will have these two sides are same. By the way, these triangles are the prototypes. Yeah, what I mean here is just one. It might be this is not the only triangle having this 45, 45, 90. So you can make it bigger. So the thing is, when you make it bigger, then you will have, like here, for example, 3, and you will have 3 here, and here this is 3 squared 2. The side lengths are it might change, in 4 different triangles, but here we want to concentrate on the trigonometric values, which are the ratios, which are the nisbet. So the nisbet, the ratios will be same. Now, this is a prototype. I said this is one sample, and you can use this one to get the trigonometric values of sine 45. Now, set 1 here and set 1 here, because they should be same. Then by Pythagorean, you can say 1 squared is equal to hypotenuse squared. The hypotenuse should be equal to square root 2. from this is by Pythagorean, and you can memorize it like or just one and then find the hypotenuse, and the rest is easy. So sine 45, take one of the 45s here. What is sine 45? 1. Okay, the opposite side divided by the hypotenuse square root 2, and cosine 45, the same thing, the adjacent side divided by the hypotenuse, and tangent 45, it's the opposite side divided by the adjacent side, is 1 over 1, which is 1. And you can do the rest. I mean, you can do the rest. Take the reciprocals of them and find the other values. Now, in some books, you will see also this can be written as after the rationalizing the denominators. So you multiply both sides with square root 2, and you got square root 2 over 2. You know, it is possible to write it this way or this way. Okay, so in some books you will see this. In some applications you will see this. It's okay, both okay. Now, when it comes to 30, 60, 90 triangle, you can use this equilateral triangle. As I said, these values are, I mean, they might change with respect to the size of the triangle, but we want you to memorize them and just to find the ratios, the trigonometric values. Now, if you ask, okay, where is 2, 1, 2, square root 3 coming from? I want to tell you, we start with this 60. This is 60, 60, 60. We make 2, 2, 2 here. Then, if you draw this altitude from here, it's a bisector of the angle. So it will be 30 and 30. You see, as you see here, and it will divide the base into 2 sides. Okay, into 2 lengths. 1, 1. Then we know these sides here 2, 1. Now use the Pythagorean. So let's say here this is h. The altitude h squared is equal to, h squared plus 1 squared is equal to 2 squared. So it will be h squared will be 3, and this h will be square root 3. Then we find the Pythagorean, we apply the Pythagorean theorem and get the altitude. Now, after you find this one, I mean, you set up the triangle. You can, you don't have to use one of them. So I will erase this one. Okay, no need to pay attention here. Just pay attention to one side of it. And by using this, okay, just let's try to find this. What is sine 60? Opposite side of 60, which is square root 3, we know, divided by the hypotenuse. This is hypotenuse is okay. This is hypotenuse. This is not altitude. Height. Sorry, altitude or height. It has to be height. So this 2 hypotenuse will be 2, and then cosine. Let's say 60. What is this? Cosine 60. Adjacent side of 60 divided by the hypotenuse, and what about the tangent 60? Tangent 60 is square root 3, the opposite side divided by the adjacent side, which is 1, square root 3 over 1. And by the same method, you can see sine 30 is like the adjacent side divided by the hypotenuse. It will be square root 3 over 2. Here, a shortcut will be no. This is okay, guys. This is not true. This is the opposite side. This is 1 over 2. Okay. If you are if you are experienced enough to use the cofunction identities, you can directly use the cofunction identities and tell, hey, this is sine 60. So what is cosine 30? So it's the same thing as sine 60. So it will be square root 3 over 2. And you can find it from the triangle also. The sine, okay, sine 30 and cosine 60, as you see, they are same here. Cofunction identities. So tangent 60, what is this? So what is cotangent 60? Let's say this is 1 over square root 3. And then cotangent 30 will be tangent 60 by cofunction identities, and cotangent 60 will be tangent 30, which is 1 over square root 3. So you can use the cofunction identities or just the triangle itself. Now, briefly, what you have to know here is if you want to use these triangles to find the values of the trigonometric values of 30, 60, and 45, just remember these triangles. This one and one of them, okay, one of these triangles. Always like 30 corresponds to 1, 92, 60, square root 3. There are also several ways of calculating them. Memorizing them. You can check it out from YouTube and just Google it, and then you will see lots of ways of memorizing it. Now, the special angles and their trigonometric values, they're listed here. You can use the triangles again. You can check, you can stop, and you can check. It will be a good exercise for you. I recommend you to stop here and then draw the triangles and try to get these values and compare your solutions and compare your values with the table. Okay. An alternative approach to trigonometric values of an acute angle in standard position. Now here we want to, okay, we want to do the same things in an acute angle in standard position. What I mean here is we want to put the angle here, put the angle, in the standard position. It means in Cartesian coordinate system. Then I want to find here, I will take a point from the terminal side of this. Let's say this is x and y. Now then I form the triangle by using this x and y. This is x and this is y. And then by Pythagorean theorem, it will be the x squared plus y squared, the square root of it. Yeah, square root of x squared plus y squared. Now I can use the same idea. What is cosine theta? It's x divided by the hypotenuse. And what is sine theta? This is the opposite side divided by the hypotenuse. And okay, one more thing, tangent theta. What is tangent theta? Tangent theta is y over x. Now, the whole idea is this. Basically, we are setting up the right triangle again, and we use the trigonometric values on the right triangle, trigonometric formulas on a right triangle, but with one difference. Here, we start with an angle in standard position. This is given to us, the line given to us. We take a point, or the point is given to us. Then by using this point, we try to get cosine theta, sine theta by using the components of this a, b, or like x, y. We use them. This is the idea here. This is an approach. This is another approach. We use Cartesian coordinate system, and we use the angle in standard position. Now, this is what I'm telling about, and we can get these, the formulas for the angle, if it is given this way. Now let's look at this example. It says find all 6 trigonometric values of an angle theta that is in standard position and the point 2, 3 lies on its terminal side. So here we have an angle that is in standard position and the point 2, 3 lies on its terminal side. So when we have an angle in the in standard position, it means it's located, its vertex is located at the origin, and we are talking about the Cartesian coordinate system. Now here theta, so okay, this is the y-axis, this is the origin here, and now this one here is the initial side, so we call it initial side of theta, and here Well, we call this one terminal side. Now, the question says, in the statement of the question, it says the point 2, 3 lies on its terminal side. So 2, 3 is a point on the terminal side. So by using this, can we find cosine theta, sine theta, tangent theta, and the others? Now, here you can, okay, if it's in the first quadrant, you will see later this theta can be here or here. But for now, we will assume, the examples here will be in the first quadrant. So you can have this one here, this. You can form the triangle here. This corresponds to 3, and this corresponds to 2, and then you can find this one square 13. And then we can use the adjacent side and the opposite side and the hypotenuse to find the trigonometric values. And also, one other thing I want to remind you is it's better you memorize the formulas here, this x and y, because making 3 and 2 here, sometimes it confuses the people in the other quadrants. So I will go for the formulas here. This x is here, y here, and this is square root x squared plus y squared. And then right here as x over square root of x squared plus y squared. So then what is x? X is 2 and y is 3. And then you can write here 2 over square root 13. So if you put 2 and 3 here, you will get this one. And in the same way, what is sine theta? Sine theta is y over square root of x squared plus y squared. So xy, here's our x is 2, and I know this is y equal to 3, and then we can put them here, 3 over square root 13. If you can put 2 and 3, you will see. And the tangent theta formula is like y over x, so it will be y will be 3, and this x will be 2. And then you can do the rest by using the reciprocal relations. Now let's see how it is done in the slides. So here, x, you put x and y, the formulas in terms of x and y, you put x and y in the formulas in the chart, and then we get these values. Now find the value of a if the point 1a lies on the terminal side of an acute angle alpha in standard position and cosine alpha is equal to 1 squared 5. Now let's put alpha in standard position, and this is acute angle. So acute angle means it's less than 90, so it will be in the first quadrant. And 1a is somewhere here. It's on the terminal side of alpha. It's the terminal side of alpha, and always remember this in standard position. The initial side is always on the positive x-axis. And here it says cosine alpha is equal to 1 over square root of 5. You can directly remember this if it is like x, y here. This is x, this is y, and the cosine theta was, in terms of x and y, it was x over square root of x squared plus y squared. Now x and y's are like 1 and a here, so I want to apply the rule here again. So I want to apply the rule with this point. X is 1 here and y is a. Now we got 1 squared plus a squared. So here, this is given to us from the question, and this we found it from the formula and the point given here, and then we match them. They have to be the same. Now this gives us an equation. Sorry about this. 1 over square root 5 is equal to 1 over square root 1 plus a squared. and then you can take the square of both sides, or you flip them and then set them equal to each other, and you get this one for sure: a squared plus 1 equal to 5, and a equal to 2, or a equal to minus 2. But be careful here, it cannot be minus 2 because it's in the first quadrant. So 1a is in the first quadrant. So for this reason, we got a equal to 2. Now here is the explanation. So it says, according to the chart, so cosine alpha has to be 1 over 1 squared plus, so according to chart means here, I mean, he's using this one. And then x and y is 1 and a. And he is putting this, the xy values here. And then matching it with 1 over square root 5, so which is given here. Matching them. I mean, they're equal. And then we get a equal to minus 2 or 2, but the terminal side lies on the first quadrant because alpha is acute, so the terminal side lies on the first quadrant, so a is positive, so we say a is 2. Now find the approximate value of b if the point 3b lies on the terminal side of the angle alpha equal to 40 degrees in standard position. Find the approximate value of b, okay, if the point 3b lies on the terminal side of the angle alpha equal to 40 in standard position. So our alpha is 40 degrees. Okay, it's in standard position. So it has to be something like this then. Let's say alpha is 40 degrees. And then it says terminal side has this point. 3b lies on the terminal side. This is the terminal side of this alpha, terminal side. So 3b is there, 3b. Okay, now 3b is a point there. Okay, I'll fix this alpha equal to 40 degrees, and 3b is a point there. And now it says, if this is the case, what is the approximate value of b? Now it gives another information here. This one information is given here, and the other information here is given in the hint, and it says tangent 40 degrees is equal to 0.84. So how can we use tangent 40 and to find b? Now we start by setting up or establishing tangent 40 by using this terminal side. So what's the rule? Do you remember the rule for tangent theta? So this is xy. What's the rule for it? Tangent theta should be equal to y over x, right? The opposite side divided by a hypotenuse. So remember this. Okay, so if you have it in your memory, so it will be easy to remember what's the rule for tangent theta, cosine theta in terms of y and x. And y and x here is our x is 1 and 3, and y is b. Then you put them here, y over x, which is b over 3. Now then we have tangent 40 in terms of b and tangent 40 from the hint, so we match them. So then you get b equal to b over 3 is equal to 0.84, and it's approximately, let's say, and b turns out to be 3 times 0.84, which is 2.452. Or this approximate value of 242. Okay, let's look at this try and check exercise. And I recommend you stop the video and try to do it by yourself, and then compare your solution with mine. Okay, now 6, find all 6 trigonometric values of an angle theta that is in standard position if the point 11 lies on the terminal side. Now basically you can draw it here. This is theta and 11 is here. So basically you will use the trigonometric formulas for cosine theta and sine theta and the rest. Okay, if you use them, this x and y is this, so you use them, you got 1 over square 2 and 1 over square 2, and tangent theta is 1 and cotangent theta is 1, and then secant theta is square root 2 over 1, and then cosecant theta. Okay, I'm using here the reciprocal relations, and if you don't remember the rule here, the xy rule, so you can do it this way, like x and y here, and then x is here, y is here, square root of x squared plus y squared here. You can use this rule here. But please try to memorize the rule with the x and y and the x squared plus y squared, because we will have x and y negative later, and then it's better you use only this triangle here. So because the students are trying to do it here or here, and then they mess up here because of they don't pay attention to the negative values, so this makes a problem. So learn it as x and y, then directly replace minus values later. Okay, not now, but in the coming sections you will have it. Okay, now let's look at this question here. Find the value of a if the point 1a lies on the terminal side of an acute angle alpha, and the cosine alpha is 1 over square root 3. And now here the problem. Okay, acute angle, again, this is alpha, this is 1a is here, 1a is here. Then what is cosine alpha? If you want to use the formulas here, it will be x over, so which is x is 1 over square root 1 squared plus a squared, and this will be equal to, again, 1 over square root 3, and then you will end up, if you solve this one, you can solve it, and then if you don't know how to solve it, okay guys, flip both and then take the square of both, and then you will see 3 is equal to 1 plus a squared, so a is equal to square root 2 or minus square root 2, but we don't take this one because it's an acute angle, it's in the first quadrant, so a is square root 3. And when it comes to this, okay guys, and so I'm trying to do it, like I don't have a space, so I don't write everything, but if it's an essay problem, you have to write all the details here. Find the approximate value of b if the b3 lies on the terminal side of the angle 50. So here we have this 50-degree angle here, and b3 is a point here, and the terminal side of the angle alpha, yes. Now it's given as tangent 50 is equal to 1.2. Then we want to find b. Now by using the formulas here, tangent theta is y over x. If you want to see, you can say here y x. This is square root of x plus y squared. It will be y over x, the opposite divided by adjacent. Now after remembering this, we can put our x and y here, x, y, so it will be 3 over b. Now what we get here is 3 over b, which is tangent alpha, tangent 50. 3 over b is approximately 1.2, and you can calculate b is approximately 3 over 1.2, and I think this is about something like 2.5. I guess it should be 2.5. Okay, that's it. Thanks for watching.